In this video, we'll cover how to apply distributed coupling to a cylindrical shell, as well as an approximately equivalent combination of concentrated loads and moments. Since the main focus of this video is on the loading, we'll rush through all the steps leading up to their application. We'll first cover the distributing coupling. In the interaction module, to apply an offset point load that doesn't reside on the shell surface, we need to create a reference point. Then create a constraint and choose coupling. And choose the reference point when prompted. Select surface, and then select the edge where we want the load to be distributed upon. Then choose continuum, and that's about it. Now we can apply the load or concentrated force directly to the reference point. And this will distribute the load over that edge. So apply a load of magnitude 10 in the negative y direction, and then we'll fix the other edge. In the mesh module, we'll seed the edges with a nice number of nodes, and this is going to make things slightly easier a little bit later on. So in this example, we're going to use 50 nodes on each of the edges. After changing the element type to S4, we can mesh the part and then submit the job. To apply the load as concentrated forces and moments, we'll switch back to the interaction module and disable the coupling constraint. Then moving to the load module, we'll disable the load that we applied to the reference point. Now we need to create a node set and apply the concentrated forces and moments to those nodes. And for this to be done, we need to make sure that the mesh has been created prior to creating the node set. So select a small region of nodes that we want to apply the concentrated forces and moments on. So in this case, instead of selecting just one edge, I will select 3 rows of nodes. And for this part, it's probably a good idea to use change the select entities tool to only select things inside of the drag shape. So here we're selecting 3 rows of nodes, and since we chose a nice number of nodes along the edges earlier, we should get 150 nodes, and that's what was selected in our set here, and we can verify that at the bottom. Now applying the concentrated force, we can select the nodes that we just created, and then our total load was 10 earlier, so we'll take our total load, divide it by the number of nodes in our set, and then apply that to each one of those nodes. Similarly, for the moment, we'll select the same nodes that we just created, and then take the moment, which is the force times our offset, and divide that all by the number of nodes, which is 150. Since we've already created the mesh, we don't have to worry about remeshing, and we can just submit this job. The stress distributions for both methods are similar, but the one where we apply the point forces has a bit of strange behavior towards the edge. And the strain energies between these two methods, they're pretty much the same, but again, the distributing coupling is likely the better option due to the more fluid stress distribution near to the edge.